So in the last chapter we looked at confidence intervals, and we were trying to estimate a parameter, something about the population, by using an interval. In this chapter we're looking at something called hypothesis testing. And this is just a process where we use a sample statistic to test a claim about the population parameter. So the hypothesis is a statement or claim about the population. So let's look at this first example. Does a majority favor a lower limit for drunk driving? Suppose that your state legislature is considering a proposal to lower the legal limit for the blood alcohol concentration that constitutes drunk driving. A legislator wants to determine whether a majority of adults in her district favor this proposal. To gather information, she surveys 200 randomly selected, and that's important, individuals from her district, and learns that 59% of these people, so 59% of the sample, favor the proposal. This sample information will be used to decide whether more than 50% of the population favors the proposal. Now, can the legislator conclude that a majority of all adults in her district will favor the proposal? Is this high enough from 200 individuals? Because the result is based on a sample, there is a possibility that the observed majority may have occurred just by the luck of a draw. If a majority of the whole population actually is opposed to the proposal, in other words, 50% or less favor it, how likely is it that 59% of the random sample would favor it? We will learn how to use a method of statistical hypothesis testing to analyze the type of issue we just described. So this method uses data from a sample to judge whether a statement about a population is true or not. And there's 6 basic steps. We're going to come up with what is called a null and alternative hypothesis. We're going to check our conditions. We're going to summarize the data into an appropriate test statistic. We're going to find what is called a p-value by comparing the test statistic to the possibilities expected if the hypothesis were true. Or we're going to determine a critical value, we'll talk about how that, and decide whether the result is statistically significant. That's very important, that wording. And then we're going to report the conclusion in the context of the situation. So consider the nature of these research questions. Does a majority, more than 50% of the population, favor a new legal standard for the blood alcohol level? Do female students study on average more than male students? All of these can be answered with yes or no. So we would have a hypothesis of the proportion favoring the new standard is not greater than 50.5 and thus does not constitute a majority, or it is greater than 50% and thus does constitute a majority. On the other one, it's either women do not study more than men do, or they do. So our null hypothesis, and it's abbreviated with this H with a sub O, that's an O, null hypothesis, is, or zero, you can think of it as zero, is that we have no change. There's no effect, no difference. Think of the word null as none, and we assume this is true until the evidence indicates otherwise. We either reject or fail to reject it. we will never ever accept it to be true. Now, the alternative is the statement that we're trying to find the evidence to support. Now, there's three ways this can be set up, and it's either that we're equal, the parameter is equal to the value, or it's not. And this is considered a two-tailed test, and that's because we're either equal to that value or it's everything else. It's not. The next one is called a left-tailed test. We're either equal, actually it'd be greater than or equal actually, or we're less than, which would be left tail. We're either equal or we're greater than, which would be a right tail. Now, left and right tail tests are referred to as one-tail tests. Only our alternative hypothesis changes. The null hypothesis remains the same in all three tests. It's always going to be equal, and I remember this because the null, if you look at the L's, that's an equal sign. Oh. So null is always equal. So we're just going to practice setting these up right now, deciding what our null and alternative hypothesis is, and whether it's going to be a two-tail test or a left or a right tail. So, according to the Gallup poll conducted in 1995, 74% of Americans felt that men were more aggressive than women. A researcher wonders if the percentage of Americans that feel men are more aggressive than women is different today. So what we're testing is that the proportion is different. So I'm going to write it in words. So the null is that it hasn't changed. So that the proportion is still 74%. In other words, P is 0.74. What we're testing is that it's different, that the proportion is not 74%. They're not saying whether it's less, they're not saying whether it's greater, they're just saying that it is not 0.74. It could be less, it could be more. That would be a two-tailed test. It could be less, it could be more. We're not saying which way. Less or more. The packaging on a light bulb states that the bulb will last 500 hours under normal use. A consumer advocate would like to know if the mean lifetime of a bulb is less than that. Is less than that. So the null hypothesis is that the mean is still 500. Our alternative is that the mean is less than 500. Less than would be left tail. The standard deviation of the rate of return for a certain class of mutual funds is 0.08. A mutual fund manager believes the standard deviation of return is less than 0.08. This is a statement regarding the population standard deviation. So the null hypothesis is that the standard deviation is still 0.08. The alternative, what is the claim? The claim is that it is less than 0.08. That's a left tail test. Less than, left. The Medco pharmaceutical company has just developed a new antibiotic for children. Among the competing antibiotics, 2% of children who take the drug experience headaches as a side effect. A researcher for the Food and Drug Administration wishes to know if the percentage of children taking the new antibiotic who experience headaches as a side effect is more than 2%. So this is a proportion, 2% of the children. So that this is going to be that the proportion is 2%. The alternative, what are they claiming? That it is more than, so greater than 2%. That would be a right tail test. The Blue Book value of a used 3-year-old Chevy Corvette is $37,500. Grant wonders if the mean price of a used 3-year-old Chevy Corvette in the Miami metropolitan area is different than that. Just different. Not claiming less, not claiming more. So the mean right now is $37,500. Grant is claiming that it is not that. It is different. That is a two-tail test. Now, the logic of statistical hypothesis testing, I think of it as they're presumed innocent until proven guilty. We're assuming that nothing has changed until the data proves it's changed. We assume that they're innocent until the data proves they're guilty. The alternative hypothesis is chosen only when the data proves that we reject the null hypothesis. Every time we make a decision, we are either rejecting the null hypothesis or we fail to reject it. Now, when we make that decision, we either make the correct decision or we made an error. We use the sample data to determine whether to reject or not reject the statement in the null hypothesis. Because the decision is based on incomplete information, we're taking it from a sample, there's always the possibility that we make an error, that we make an incorrect decision. Now there's 4 outcomes that can happen. We could reject the null hypothesis when the alternative is true. That means we were correct. We could not reject the null hypothesis and the null hypothesis was true. Again, we were correct. But what if we reject the null hypothesis but the null hypothesis was true? We consider this a type 1 error. This is like saying that the person is guilty when they are innocent, when they are true. Now the other type of error, we do not reject them, but the alternative was true. This is saying that we failed to convict them when they really were the bad guy. So let's look at that a little bit more. That analogy. If the innocent person is not guilty, or we conclude that the guilty person is guilty, we're correct, right? But if we convict an innocent, that's type 1. We reject the null hypothesis and we shouldn't have. Now, if we let the guilty person go free, that's a type 2 error. A type 1 error is sometimes referred to as a false alarm because the researcher mistakenly thinks that the parameter value differs from what was hypothesized. Similarly, a type 2 error can be called a missed opportunity. We didn't have enough data, and we failed to realize that we did have the data to convict that person. So let's think about this. Suppose you have the following, that a house is on fire or the house is not on fire. What's the type 1 error? The type 1 error is I reject the null. I reject that the house is on fire. That the house is on fire, but it really is. A type 2 is I fail to reject that it is on fire. So I think it is. I call a fire department, but it is not on fire. I didn't go double check that there was smoke. I didn't double check my evidence. The Medco pharmaceutical company has just developed a new antibiotic for children. We looked at this earlier. Among the competing antibiotics, 2% of children who took the drug had side effects, and they wish to know the percentage if it's more than 2%. We looked at that earlier, that the null was going to be that it still is 2%, and the alternative was that there's more than 2% that have side effects. So a type 1 error is that I reject the null. I reject that 2% have headaches. When 2% really do. A type 2 error. I don't reject that 2% have headaches. In other words, I think it still is 2%, when actually more than 2% have headaches. So type 1 error is I reject the null and I shouldn't have. According to the Centers for Disease Control and Prevention, in 2005, 15.2% of 10th graders had tried marijuana. The Drug Abuse and Resistance Education DARE program underwent several major changes to keep with technology and issues facing students in the 21st century. After the changes, a school resource officer thinks the proportion of 10th graders who tried marijuana has decreased from the 2005 level. So he thinks it's decreased. It was 0.152, that's 15.2%, no change. He thinks it has decreased. That's a left tail test. If you fail to reject the null, and suppose in fact that the proportion who have tried marijuana is 14.7, it's less. Is that a type 1 or type 2 error? If I fail to reject the null when it actually was lower, that is a type 2. I failed to reject it. In the next video, we'll be looking at the different testing methods. This is all still part of the same section.